So I just wanted to explain a bit about the technology behind this little solar system story. And I do when I give this workshop in school classrooms to a number of the age groups. So I'll explain part or all of how it actually works. And there was a nice phrase that came out from one of the classes. It was actually a year 2 class in the school recently. And I'd said various things, and there was a couple of girls that sort of fed back. They're thinking about this, and they come up with this lovely little phrase that says, "It's not magic, it's science." And basically that's because I was saying that it seems like magic, but magic is just things you don't understand how they work. And when you do understand how they work through science, you can explain things through science. It's still as exciting as before, but you now understand how it works. So I'm going to explain how it works. And as I say, there are aspects of this story that I explain how it works because it signposts different features of the microbit that the children can then use to code. So we have a teacher microbit that I'm controlling all this from, and we have up to any number of student microbits. They all receive a message that's sent via the radio link on the microbit, and the microbit has a little wiggly line on the back, which is the aerial, and the aerial sends a radio message, just like you might use a radio message with Wi-Fi or Bluetooth for your headphones or anything like that. It works the same way. And what I do is I decide that I want to test my microbit, so I press the B button and I get a little happy face, so I know that all the microbits are working. And then I go into part 1 of the story, and part 1 of the story is using the light sensor on the microbit. And what the light sensor does is, depending on whether the light is shining on the microbit or not, the light sensor is turning the screen on and off. So you can build projects with the light sensor. So for example, you can build a project that works out whether someone has opened the lid on your cookie tin and sets an alarm off. Step number 2, and this is a little animation of the moon. So an animation on the microbit is just a series of images that plays in a sequence on the display. So if you can design little images on a grid and put those into the code, and you put those images following each other in sequence, you can get little animation. So that's how the animation of the moon works. Step 3 is moon bounce, and all the moon bounce does is when I press the A button, it sends a little message, and what comes back is the A. And when I press the B button, it sends a little message, and what comes back is the B. You can also, if you know the amount of time and the speed of radio messages, you can work out how far away the moon is. Step 4, this is the falling star. So what step 4 does is I have a little star on the screen, and when the microbit senses that it's been shaken, and the way it senses it's been shaken is you use a little chip on there called the accelerometer, and that's the same chip that you will see in a mobile phone or a tablet, so that when you turn the mobile phone or tablet in different ways, it rotates the screen to face the right way. So the microbit uses the accelerometer to sense that you've shaken it, and when I shake it, it clears the screen here, and it sends a little radio message to say star, and then all the microbits, when they receive that message, they display the star on the screen. Step 5 is the compass, and the compass is a built-in feature of the microbit. Again, there's a chip that's used for the compass, and what that does is that measures the direction and strength of magnetic force, which picks up the magnetic field of the Earth, and then as you rotate the microbit around, the arrow will change direction. Step 6 is the magnetic sensor, and that uses the same chip that we use for the compass, just in a slightly different mode. And what I have with my moon rocks, so this is Exhibit C, these are made, these little rocks, I put them in these little display cases just so they didn't get damaged. They're made from polymorph, and then they're painted with acrylic paint. I just mixed some white and black paint together to make them a sort of grey colour, and they're blue tacked on there so they don't fall out. And Exhibit C is the only one that's magnetic, and what I did is before I formed the polymorph, I put a little magnet inside and then I formed the polymorph around it. Polymorph dries or sets within about 5 minutes, and then you can paint it, and the paint dries quite quickly. So that's the description of how it all works.